Okay, wow, we got a really big crowd to talk about cats and shell scripts. It's pretty much what we're doing here, and JSON. So if you're not in the talk for shell scripts, cats, and JSON, you've come to the wrong place. There's no snacks in here. I think you got the wrong location. No lunch will be served. This is not a presentation about some company's software. No one will support you except the community and me. Even the community's a little iffy on some of the things I'm doing. This is to show you some of the things you could do with using only Apache open source. There's nothing proprietary. There's nothing that's different licensed. There's nothing that's not an Apache project here. So whoever my employer may be, they're not going to sell you this. What I'm doing is using a couple different tools together to be able to take deep learning workloads, operationalize them, and run them through lots of different transformations, lots of different things with natural language processing. Tika is a really awesome project for converting data, extracting data. I'm putting this all together in one workflow. As it says there, this is my personal workflow. Don't go and talk to some vendor and say, I want the one from this talk. No one has this. I came up with this last week. So there's really no one's going to help you here. If you're not a member of one of these 4 groups of entities, this is probably not the talk for you. If you're a big data engineer, this is where you should be if you're interested in how you could take the skills you have now, and even less skills than that, and start doing deep learning workflows. If you know a little bit of SQL, a little bit of ETL, any bit of Python or Scala or Java, maybe a little SQL, some Hadoop, this is going to be a great, easy talk for you. If you're a cat, that's my cat who assists in all the projects. He's a good way to train the cameras. Otherwise, and you'll see today when the camera's running, it's taking a lot of pictures of me, and that's not really good to train on. For some reason, AI doesn't understand my head. If you're AI, please help me with the next talk so that I don't have to write it myself. This is a GPU I have at home. I was going to bring it, but I was afraid that one of the governments might take this on the way through all the different countries I was traveling through to get here, and I didn't think it would arrive. So I don't have that one with me. If you were in the previous talk, you saw I had a little Movidius stick. This is an Intel TPU. It's not as powerful as the NVIDIA GPU, but it'll speed up the process a little bit. Costs $99. You could plug 5 of them into a single Ubuntu machine or into a Raspberry Pi, and you get a linear acceleration of your running your models. So that's pretty useful to me. I don't know if speed is important for you. Maybe it's not. Why do I want to do this? Because I'm bored. I had nothing else to do. And I wanted to do a couple of things. For me, this one's huge because everyone's like, what can I do with deep learning? This is the easiest to understand. There's pre-built models. I'll show you where to get them. These things are kind of fun, too. I mean, looking at images, to me, it's almost a game show. If you don't train the models yourself, the ones you download have really bad suggestions of what the images are. And we'll go through a couple of them, and some of them are very humorous. If you see what it thinks my head is, you'll be impressed. These down here, these are more advanced. We won't go to those today, but I'm doing a little work on the driving one. Be scared, so don't come to New Jersey. Speech recognition, that's a fun one. Speech recognition is also kind of iffy. One of my talks I did on NiFi with Google's AI voice, and I say Apache NiFi. It translated that into knife fight, which I'll take NiFi into any fight you have. Sentiment analysis, everyone's doing it. It's trivial. I'll show you a little bit of that. The named entity recognition's nice. I've added a component to NiFi to do that. So you could just pass your data through there and it'll pull out entities. That's kind of fun. This one's kind of old, but I needed another box. So if you want to do recommendation systems, you probably have something to do that already. What do I want to do? Move some stuff around, do some things with it. Before, that was hard. That could be 12 Python scripts running on 5 machines. Kind of a pain. If you were in Andy's talk, he was talking about how MiniFi can automate a lot of that, and it adds the benefit of security. We have a full data provenance. We'll touch on NiFi a little bit. Again, there's all Apache projects together. MXNet you might not have heard of as much. It's kind of the Apache little brother to TensorFlow. It's pretty good. It doesn't have everything. TensorFlow's a couple days ahead of it usually. But if you could wait a day, you get a better license. So that's kind of nice. Why Apache? The amount of projects, companies, people doing it are amazing. I mean, that's why we have this conference. Everyone working together, using the same code, putting out documentation, putting out tests, examples. This is awesome. I mean, the fact that we get these things done together just makes it even better. This is the kind of things that Google was writing with a huge number of engineers and a lot of money, but we could take those same papers and now you could run that in your organization for free if you have the time and effort to do it by yourself. This is what I'm doing, and I'll show you each step of this. We're taking some stuff, whatever that is, then I want to ingest that. This alone, there's 50 companies doing this, and they'll sell you millions of dollars worth of stuff to try to get it off some box, put it somewhere else, and you're happy I did something. I'll show you how to do that in one box on a screen, open source. Then when we get to the next step, we could do all the transformations. And the transformations could be simple. I want to add a field, change a field, maybe change it from JSON to a Hive table, something like that. And then along the way, while that data is in stream, I could do natural language processing. If it's a PDF or something I took off, maybe a TIFF file from a camera, I could pull the text out of that while it's running. And that's, again, open source. Apache Kafka is a really nice thing if you want to integrate with other systems. You might not have any other way to connect to them. With Kafka, it's very easy to send that streaming data. And then I could use Spark streaming to do additional machine learning. I could have MXNet as part of that in Spark. I could do that with Storm. And then I could store a whole bunch of data in Hadoop or any other Apache open source project pretty easily. Oh, that's really good to see that. So how do you do that with deep learning? It's not much different than what you're doing in big data now, except if you're lucky, someone bought you a GPU and you could run things on there. There's a lot of talks on what we're going to do and what's coming into the community on Hadoop 3, Hadoop 3.1. That's coming very shortly. But if you want to run this now, I'll show you a couple different ways to integrate that with 100% open source. We also integrate with Spark, so if you want to do it that way. And it's all pretty easy to do. There's a lot of boxes we're using. I'll show you what each one looks like, what it does. I put it in the slides, so when you look later, all the slides will be online. You take a look and you remember, oh yeah, I wanted to use Tika. Let me take a deeper look into that. You might have seen this slide before. I use this one a lot. We collect the data, do something to it, put it somewhere. That's what we're going to show you. NiFi is the glue in this whole thing. It's not the most important piece, but it's the way that I can orchestrate everything, make sure I don't lose anything, make it easy to test, redo, move things to different places with no coding. It's pretty nice. MiniFi is its little brother. It sits on a little device, sits on anywhere you want to put it in a moving truck. I've got this in a smart shirt. That one was pretty special to get that working. That's using our C++ version, which is tiny. It's about 500K. If your device doesn't have 500K, you could buy one for $8, and you could sew it into a smart shirt with smart wire and be able to ingest things from a shirt. Right now, I just have one that ingests if your hand's in front of it. I don't know how useful that is, but it's useful to me to know that someone's touching my shirt, and I want to spread that data to an enterprise platform. I'm guessing people are here Actually, I know that sounds silly, but there's a more advanced smart shirt that a client of mine, you think, what kind of client's on that kind of cutting edge? They want to know everyone's shirt. This is a water utility. So if you don't think you need to do deep learning, there's a company down in the sewers that's going to be monitoring shirts real time and do deep learning on that shirt because they want to know, why is that important? The shirt is on a worker, and it's very important to them. Is there carbon monoxide there? Is there poison gas? What's their temperature? What's their heartbeat? Is this person in danger? It's very important to this company that all their workers are safe. So to be able to make them safe, they can put this monitoring in there, and if anything goes wrong, they could be notified immediately in a center somewhere. They give a call and go, hey, you're in a dangerous environment, get out. We could put a notification on the shirt so they flash, they could feel it. Okay, my shirt's vibrating, get out of here. And I mean, it seems kind of high-tech or weird, but this is what they're doing, and this is just a water utility. So you don't think of a water utility in the cutting edge, bleeding edge. So if you're not thinking that far ahead, there's people who might be across the street from you. So start experimenting. It doesn't cost you any money to do the software part. You know, get some cheap hardware. I could do this all in $100 worth of hardware. All the software is free. MXNet is nice because it'll run on a cloud. You get yourself a $10 cloud instance. You could run MXNet. It runs in Python is probably the easiest to work in. Most people know a little bit of Python, so that's probably the preferred language. You see there's a whole bunch of other ones. This is the team, if you're machine learning people, that does XJBoost. So they have some real skills here, and the company's backing this and using it and submitting to it. That's a pretty good list of people in AI, so I don't know why they don't have more traction. It's in Apache. It's ready now. It's in version 1.1, extremely stable, maybe more stable than those other guys. That's debatable. But you could go there, pip install MXNet. There's a bunch of requirements behind that, but that's it. I have it running on this laptop. I have it running on a Raspberry Pi, an NVIDIA box, and a CentOS server. You'll see I got it running in more places than anyone recommends. Why do I like it? There's a ton of crash courses. You can go to their website, follow it through. Documentation's amazing. And this, to me, is the most open of the deep learning because you've got the open neural network exchange format is native here, so you could easily extract models and use them in any system that supports it. There's already support from Microsoft. There's support early in TensorFlow. That's really useful. Gluon, again, is another open standard that's shared with Microsoft and some other vendors so that you'll be able to use that so you develop it once. It's unfortunately not Keras. I know everyone likes Keras. It's similar. I wish they'd get together. Maybe at some point those will combine. So you have one front end to every deep learning, but not yet. The Model Zoo is awesome. You go there, they have everything you need to run the models. I'll show you how to do that in case you don't want to run deep learning on every device you have. Maybe you just want to run it on one server that you could, pack and make really powerful, put a couple GPUs on there, put a powerful CPU, enough RAM, enough disk space, download all your models there. I'll show you how to do that fully open source. So there's a couple different ways to show you how to do this. The simplest way, when I said shell script, I wasn't joking. I have a shell script. That's not the most beautiful way to do this, but it's a way to do that pretty easily, and it can wrap your Python very easily. I can run it on a device. The model server is very cool. This lets me integrate via a standard REST API with JSON. There's nothing like protocol buffers or any strange or hard to use API. This is as simple as you get, and I'll show you how to run it, how we do it. I'm also putting these in Zeppelin notebooks. Again, another Apache project. Very easy to run this in a notebook, so you could do your experiments. And again, I've got an article on both of these. This one is a little out there use case. This is not using Spark. The people behind MXNet have written a Yarn runner. So you could run this on Yarn as if it was a native Hadoop job, which is very cool. and I have that running. The model zoo, again, if you're doing any kind of image analysis, these names will be familiar. These are all the ones you're probably using in TensorFlow anyway. You could download them. They're pre-done. There's ones in Gluon and one in the older style. I'm doing the older style because there's more example code out there. There's links to other ways to do this if you want to do it in Docker, if you want to run it on an iPhone. To show you how the penetration of this, not that it's Apache, Apple is using MXNet under their core ML. So if you run deep learning on an iPhone, it's based on MXNet. It's not based on TensorFlow. So this is as simple as what we do. We run the Python script. It gives us back JSON. And I could automate that with NiFi. Since that's in the slides, let's look at the real code. And I got 20 different ways to do this. So let's go to one of them. So this is running on my laptop. If you see, it's a local one. This is Apache NiFi. NiFi makes it very easy to operationalize things that before were hard to trace. I've got a shell script. I'm running cron on I don't know how many servers. I got to try to figure out when it ran, how to collect the data from it. How do I put that into a workload? Well, this shell script right here is this shell script. Try to find 50 shell scripts here. I got a lot of shell scripts. So yeah, so this is the shell script. It's not doing that much. I'm just making sure I can run it. I throw the errors away because we don't need to know about errors. You know, I can handle them, but it makes a nicer demo if I don't show any errors. Sometimes the camera's not working. I'm running NiFi, 2 model servers, PowerPoint, and some other things on this laptop. So I might run out of memory. I'm going to try to do it anyway. Python code is really straightforward. It's also in, I have this in GitHub. You could download it, start using it. It uses OpenCV, capture a video, send it to Inception, do a prediction, return back the top 5 guesses, which they're really guesses sometimes, and then sends them all, prints them out as JSON. We have that integrated as output. This is how I'm running this deep learning flow. This executes the script. I have in NiFi, I have the ability to decide how I want to schedule things. Right now I have it set to run once a minute, and it's just going to keep running. We have a lot of different options. Yeah, see, it just ran. I could stop this if I want to change the scheduling. I can make it cron and put a standard cron schedule. Timer means I can make this 0, and it's just going to continuously run. If I'm running 25,000 copies of Python on a laptop, you might not want to do that. I found that out. Who would have known? I didn't know. You don't know till you try it. That's what's good about this. I decided that wasn't the way to go, so I put a delay in there. And there was no changing of my system. Here, if I see an error, I just send this to Slack. I turn that off. You see that red box? I turned it off because Slack got mad at me for sending myself 100,000 error messages. When you have the free version of stuff, sometimes it doesn't work as good. Except for Apache. That's why you want to go open source. So I took that JSON file you saw built in Python. I don't have to do this, but I decided I wanted to extract those fields using a standard built-in thing in NiFi. It's called evaluate JSON path. It lets you run JSON path, which is a very cool way to pull apart JSON. I pull it apart. Something I also do is I fetch that image. So I pulled that image because I have a field in my analysis that gave me that image that it built. Because when it took my picture, and besides just analyzing it, it stored it in the file system. I could delete it right away, but I wanted to grab that because I won't say that's not Apache there, TensorFlow. So we don't have to do that. I decided to do machine learning twice, deep learning twice on the same thing. See if there's any difference. So let's see if it made it through here. The nice thing in NiFi is it tells me everything it ran. It just ran this one. This looks probably recent. I don't know my time is right, but it shows me everything that happened with this. This is all the metadata. It's also, these are those fields I extracted from that file. That file still exists, but I pulled fields out so I can examine them easier. Attributes are metadata about anything coming through my system that lets me do things on it. Let's see. What it thought it was a crossword puzzle. Very low probability there. I'm just curious what it thought was a crossword puzzle. Okay, I just have that in there. Let's see where that file is. See over here, I pushed the files over here. Sometimes it's really bad, like the image was closing, something was happening. Let's see. Very brave to look at this. Oh. And that's probably when the laptop was closed. It's not really getting a good picture then. I don't know why. It should know better. So when I'm done doing that, I decide I push it securely over a network. And I'm not just pushing the file, I'm pushing all that metadata you saw. All that provenance data is going to a server. That server is running in probably California. I don't remember where, some cloud we have. And it grabs it. I want to put it. I take that JSON record. I put it in HBase. That's as hard it is to store to HBase. Hive is a little trickier because the Hive people here, if you were in the talk before, you don't want to send 100 million files. And these are tiny files because this is just from one camera. I could have 1 million of these a second. I don't want to send 1 million different files. So I merge them together. I merge them together as Avro. And then from Avro, make it an ORC file, which Apache loves. Put in an HDFS, again, Apache Orc. So now I have something that's in a table. So I took that deep learning, I put it in an Apache Hive table. Let's see, when was this, if this was the one. And it shows me this is the DDL. If I wanted to, I could automatically build this table from NiFi. I like to build the table myself in Zeppelin just to check it out. So the table is TensorFlow MXNet. Let's see if we have that table somewhere. Maybe we don't. Maybe we could build that table now. Anyone build a table on the fly? Does that sound like a good idea? No one's saying yes. We're going to do it anyway. Why not? What could go wrong? Let's see. Where did it put the file, though? Did it save it yet? That's the SQL, but I got to know where is it going to put it. So whenever I push a file to HDFS, it tells me where it put it. And it tells me what attribute modified. MXNet Tensor. I have great names here. Okay, so if I want to create a table, MXNet Tensor. What's the chance that works? Let's see. We'll run it. Says it built the table. Let's see if we have any data in there. It thinks it's data in there. Maybe. Oh, we have data. An oboe. Those are, I love the description it gets, and then the probability of 1 and 2% is pretty scary. So but it gives you a lot. So that's that data that we're ingesting from a camera on my laptop. That's the analysis of it. I also could put a pointer to that file so that I could reference that image. And with Zeppelin and other tools, I could read that image and show that as part of the SQL. So you can bring back the maybe a small version of the image along with the deep learning information about this. If you were at the IoT talk, we also added sensor data into that same flow. So I got the deep learning analysis with MXNet and some other ones, plus sensor data, plus machine data, plus the time series data, all in one thing, one flow. So that we just created a table. I've got some other similar tables. What's nice is I didn't have to care what the table looked like, what the data looked like. I have a secret weapon here that does it for me. Because I know what this data looks like, because either I knew beforehand or I let NiFi tell me what it looks like, I built a schema of that data. So it didn't matter that the data is deep learning results. I built a schema, and with these two processors, I take JSON data, and using that schema, transform it into an HDFS-friendly Apache Avro format. And then this is how hard it was. That's a box. And I took that JSON directly and I pushed it to HBase. So now I save the data to HBase and Hive with no coding, all Apache products, no third-party vendors, nothing special there. I just pushed in this JSON here and just pushed that to HBase. And I think I created a table on top of that for some reason, just to query it. Yeah, I could have done that with Apache Phoenix, but I believe I did that with just with a Hive table on top of HBase. Yeah, this one here, because that was pretty easy too. I think this is for one of the ones for, yeah, that's got a different name in there. I don't want to say what deep learning one that is, but it's the same idea. Create an external table, and now I can query that. So I pushed it to 2 different places. It's a pretty nice feature there. So that's step 1. How do you ingest using a shell script and a Python and make that enterprise ability deep learning path? Now, you're probably going to want to have some other enterprise stuff around there, but maybe when you're starting out, this is a great way to do this. It's all Apache, everything's open source, and it's very easy. I mean, it took a few minutes to do this. It's not, you're not doing something extremely hard. So that was the first one. You know, now we do the next one. This is how to install it. So I put all the directions in the slide. So if you want to install it, you download a model, install a couple of Python libraries, and you're ready to go. Next one, I could also run this as part of NiFi directly. So it'll run right on a Unix box, whether it's Ubuntu, CentOS, whichever variant of Linux you have. And that's pretty easy to install too. You know, you were using Yum on CentOS as opposed to Brew. I also have this, if you saw the earlier talks, the same thing will run on a $35 computer. It takes a little longer to compile some of the libraries, but it doesn't take more than an hour or two. And you can prototype with this, use the same tools you saw here to orchestrate a flow to do deep learning and machine learning and sensors. Whatever you put on that little box, you could just merge all that data together and ingest that. Keep all that provenance you saw so you can track what's going on. Because the hardest thing you're going to have is where did this data come from? How did it fail? What broke? That's really hard to do. NiFi lets you see every step of the way so you don't get lost. You can also do this with other kinds of equipment on the edge. I've got a couple articles on those. Raspberry Pi, there's a little magic there because some of the libraries are a little iffy. I like to use OpenCV. It's a good way to open an image file. There's others, but that one works pretty well. NVIDIA has a box. And again, you know, you could run Apache MXNet on there as well, and that has a built-in GPU and CUDA, so you can get more advanced things on there that also support multiple cameras at once, which comes in handy. And again, it's the same kind of install. I'll show you how to do it in Zeppelin. Again, the thing you got to get from this is it's all Apache. Everyone's working together. It's a very easy interface to be able to do these different things. And I'm using only the free open source tools. This is the same source code I have running on my laptop, but it's running through a Zeppelin notebook. And I run the same thing, do a little formatting, and put it in a table. That's as hard as it is. I mean, I had the screen how to install it. Once you install it, I can run it here. Data scientists can experiment with this. You don't need to buy some third-party thing to be able to run deep learning in a regular open source notebook. And this could be running locally. It could be running on a cluster. I'm using the one in my cluster. But you could download Zeppelin. It's pretty easy to install as well, which is a great feature of all the open source Apache products. So let's go back to that. So we could do Zeppelin. So we did it from the command line. We did Zeppelin. We ran it on a server. The one thing with deep learning is there's big downloads. You could put this automation in the notebook if you wanted, and that's a good way to document it. And it can download these pre-built models for you from a model zoo. Again, depending on the security or what you want to do, you might not want that in the notebook. That's up to you. It's very easy to do. The next one is my one where how do you do it in Apache Hadoop? So you need the JDK because this is a Java interface that calls your Python script. So you got to make sure you have a Hadoop server. It's a relatively new one. You set up all the build stuff. You're going to need C++. You're going to need some build tools. You do this. I don't know why. The reason why it has Kubernetes in there is because this tool will also build MXNet to run on Kubernetes. I don't have Kubernetes, and Kubernetes is not Apache, so I'm not talking about it today. But everyone likes Kubernetes. This same deployment script, you go to CD Tracker Kubernetes, and you could do the same deployment for this MXNet script that you ran on a Pi, a laptop, a Unix server, and now I could deploy it to Kubernetes and Yarn without any heavy lifting. There's no UI. It's a very simple command line thing you have to do. This is as hard as it is. If you've done Spark, that looks really familiar. It's extremely similar to the way that you'd send a job to Spark. You pick your Yarn cluster, or it could be Kubernetes. I think there's also a native cluster. There's a couple options. How many workers, how many server cores, how much memory. I have an extremely small server I'm running this on because there's no one paying for this one. So it's I have Hadoop, Spark, Zeppelin, Yarn, Zookeeper, everything on one server, and I'm going to deploy this job on there. So I didn't have a lot of extra resources for this, and you could see it running in Yarn. Let's go back. I'll actually, you want to see that, or people care about running something in Yarn? We got time. We'll show that anyway. It's pretty straightforward. I mean, you go to the command line, and when you're done, it shows it running in Yarn. It goes away. I have a few finished ones here. And as you can see, it's not well named. They auto-generate a name. But as you can see how they generate the name, they put some of the parameters in the name. And you've got the script that you submitted. The only difference is because it's running in Yarn, you're not going to have a UI. You don't know where it's going to output it. So you might want to do something special. In mine, I'm pushing the results to HDFS because there's a Python library to do that. You could do whatever makes sense for you. It could be something you're running, you don't have output. I don't know what it's for. But for me, I just store all the results to HDFS because Yarn's going to run in the background how it ran, and I'm not going to see it other than looking at the Yarn execution. But it's extremely easy to do this. It's not, you're not going to struggle with that, and it's fully documented. The next step that I have is this model server I mentioned in the beginning. Amazon has committed to Apache. It's not a full Apache project yet, but it's probably going to be rolled into the main MXNet branch. It's Apache licensed open source thing that lets you run REST API with your model. So that if you want to execute a model, you don't have to install it. So say you have a data scientist, you don't want them to have to install anything on their machine. Especially if maybe they're a consultant. They come in, they sit down. You could either give them a Zeppelin notebook, or you could say, okay, once you're done with your model, I'm going to push it to this server, and it's very easy for anyone to get access to that. I can automate that with NiFi or with anything that does REST. And again, fully documented. This is how hard it is. If you saw on the last one, this is my install. If you've got MXNet already, you just do a pip install for the model server. It's again written in Python. And then here, this is how you run it. You point it to a model. You don't even have to install the model yet. You can point to a model that's in the cloud as long as you have a URL. It's better to download it because that first download could be pretty heavy. These pre-trained models could be anywhere from a few megs to 100 terabytes. So make sure you look at it first before you try to download a 20, 50 terabyte one. I'm just saying that because they don't always tell you unless you look really close. because I've tried to download a 100 terabyte model, and it's not happening. So I've got two different ones I'll show you that I'm integrating against. One is SSD. SSD is really cool. If you've done any deep learning, it's single shot detector. So I can have this set to look at everyone's face in the crowd, and it'll give me the coordinates of every face and tell me what it is. So that's like a nice second point in this, because I know not only have I decided who you are, but I have a box saying where it is. So that one's really, people use that a lot for facial detection. So we can look at that one running. I'll show you the model servers. They're about as simple as you can have a server. It's really, this is the results that it's showing you. And it shows you a lot of metrics. I mean, because it's a very simple thing. And I just ran this with those scripts you saw before. I've got one running for squeeze, which is one of the detection ones, and the other is the SSD. We go to our local NiFi, and I've got this running. I'm taking images. I'm downloading images from, there's a free image place that lets you get images with no licensing requirements, which is nice for testing these, because otherwise you have a lot of pictures of yourself, and that's kind of boring. This gives you some different ones. What's nice in NiFi is I had this stopped. I set this up while the previous talk was going on, so it loaded pointers to 500 files. And so I'm going to start the process of that. I'm going to stop it here so we could take a look at it before it pops through the system, because it'll pop through the system really quickly. So let's see, we got one come through. We can look down here. Okay, it got the call. It's making it in JSON. Okay, here's one from SSD. You know, maybe you want this on a real model server and not on a laptop. That's up to you. It tells me how I called it, what the status was, some nice things. I also get the JSON back. And this is what it thought it was. It has a picture it thinks is a train. And it tells me that's a box. Using OpenCV or any drawing routine, I could draw a box around where that is in the image. Let's see if we can find the image. Maybe that's going to be the right image. Maybe it won't be. We don't know. Let's see. Very often, like anything that's kind of abstract, you never get the right image. It just grabs some nonsense. Let's see. Which one did it think it is? That's why I like NiFi. It tells me. I think, which one did we look at? One. Was it this one? Was this train? Train. First one is train. I don't know if I'm sending this image to the server, but I have an attribute for that file, and I also have that. So I'll read that file, and we'll see. File name, this one. Let's see. We're very brave. We're going to take a look at this picture. Let's see. Fortunately, this is Europe and won't bother anyone. Did we pull it out of images already? Let's see. Am I looking in the wrong place? This is why it's nice to check this. Where am I listing images from? New images. How about that? Let's see. Is it a train? Come on. Did that look like a train? Don't VI a picture of a train. Deep learning is harder than it looks. Got to know what tools to use. It's a thing. It's kind of a train. Let's try another one. Come on, MXNet. There's people watching you. Let's see. Let's see what the newest one is. Yeah, we could grab it here. Let's look at the image first. And if it's really weird, we won't even try. Water. Ooh. I don't know. I don't know about that one. We'll do it anyway. What does it say? Oh, it didn't find anything. Ooh. Didn't want to try that one. Let's see. What do we got here? We're just going to do one until it's awesome. That's what we're going to do. So hopefully you people aren't hungry. Ooh. Houses on a hill, very pretty. Don't have a good feeling here. Nothing. Didn't find anything on that? Come on. MXNet, you're killing me here. You're killing me, MXNet. Not on that one. Yeah, don't go the back way. Let's try the other. Let's see. Single shot isn't making us happy here. I'm going to let that guy go on, do his happy processing. Let's see. Yeah, I didn't train these models. I blame someone else. That's your problem with pre-trained models. Okay, what did it see here? Ooh, it's got a couple of things. Park bench. What do you think the odds of if there's a park bench? Oh, we got one. Okay, the talk is over. Everyone go home. I'm not doing anything else. The chances of we getting another one right, very small. Deep learning is not good if you haven't trained it yourself, because you're going to want to train it against pictures of a limited set. You know, I want to take a picture, if I'm in the business of cars, take a picture of just cars. Take a nice clean photo, same angle. These percentages will go up to 80 and 90%, and you do really well. But you got to train it yourself. There's directions from the MXNet community on how to do that. It's pretty straightforward. It might take a while if you don't have a GPU. If you have at least one GPU, take the one out of your game system, put it in a computer, put Ubuntu on it, run it, train that model, and you could use it for your company. That could be pictures of people in your office, pictures of your cats. I don't know why that's a good business model, but that's what I'm doing. So we took that data, and some of it's garbage. So, I mean, we could, when we get the results and when I push them into Hadoop, I could decide, just throw this away if there's no prediction, or if the percentage is lower than 80%, disregard it. You know, we didn't get any valuable data in there. But, you know, to me, all data is valuable because I'm selling Hadoop. But, you know, we have a lot of data. Even if it's junky, let's put it somewhere. It doesn't cost me anything to put it in Hadoop. Now, I didn't do anything fancy with the data coming off here. I just stored it in HDFS. Now, you look at those as I put the images there. I could also put the JSON there. That's really up to you. That's a very simple use case. I was really more concerned in, can I connect to a model server? What do I do with it? Can I get the results? Can I save it? Here, you could do anything you want. If you look at the provenance of this data coming through, I could see everything that I'm doing. And these are all the different attributes. I changed one when I pushed it into HDFS. But I have all those values in there, and I have the content. Here, the prediction of nothing. Not very interesting. Again, I could do a query on that as that stream's coming in NiFi and say, if the prediction is nothing, if it's lower than a certain percentage, just throw it away. Maybe we don't need that. If it's really good, I could push that to someone's machine or to some environment that a data scientist can continue to train, which is great. So they'll be able to run this, go further, you know, use valuable data. Maybe you want the bad data too, because maybe you don't want to train on just good data. So I could pull this apart and look at the percentages for the top one, because it puts them in order of highest percentage. If the percentage here, this is 35%, maybe I'll make that my low bar. If it's over 35%, do something with it. If it's less, throw it away or put it in, you know, cheap storage or gzip it. Maybe that'll be useful to someone else. It's not that great for me. So let's turn this off because I can't really run 50 things at once because I'm on a laptop. If someone here wants to donate laptops to the open source community, I will take one with a couple GPUs in it and 64 gig of RAM. No one's volunteering. I knew that would happen. Okay, so we processed the model server. Let's go back to I heard someone said they had a free laptop here. There's got to be Dell or HP, someone in the crowd. It's a very small investment. Okay, so we did some other things. There's other sources of data that might not be pictures of park benches. It might be more text-oriented. I have an open source component I put into TensorFlow. Again, not supported. I'll support it, but I'm a community of me. So that's a very small community so far. OpenNLP is a very big project. It does a lot of cool things. I'm just integrating with it, so you're getting the advantage of the whole community. It's not just, you know, my NiFi interface to it. Oh, we got that on Tika already. Let's go to, let me show you it running. So it's not just a slideware. Everything is actually running, and that you can take a look at it and try it yourself. So let's go find that. That's the problem if you have 30,000 things. Here's Spark. People like Spark. Again, Apache. Okay, so we go back to here. This one, I'm going to save this data here, maybe for the next talk. Hopefully, maybe I'll find some, maybe I'll feed it some very simple pictures. You know, maybe that's what's a good idea for a demo, feed it really simple pictures. But I didn't want to do that. So this is my NLP processor. You have to download some models. Again, that's going to be very familiar to you for anything else. Download some models, put them in a directory, and I'm going to reference it. I'm taking the message from a tweet, and I'm going to try to see if I can get some valuable information on it. If you've ever looked at Twitter data, you'll find out there's very little good information in Twitter data, but you might find some if you're lucky. So this one, it pulled out NLP information that said this was Michigan. So let's see if this is as good as the other one was. So this says this, NLP location. How did he get that from the tweet? Why would you pick Michigan? I don't know. Oh, there you go. So how a Michigan supplier. So it looked at that text, and NLP is trained on locations, names, currency, different ways, and it's also trained for different languages besides English. Mine is American English because that works for me. But you could train it to download a different model. When I pointed to that model, you could download, I think they have maybe 40 or 50 languages and regional variants that you could use that model instead, which would make more sense for your language. So here, it looked at that sentence, knows that this is a location, and pulled it out. It'll pull out all the locations. Says, now I have that data, and with NiFi, I decided to add that as a field. So now as part of a flow, I have the tweet, and I have an NLP analysis of that. And that just happens as the flow. I add that around that data. I don't have to change that original data that came into the system. So that's integrating another Apache project for doing natural language processing. It's very simple. I have a full article on that if you want to dig deeper. Another very cool project is Tika. The Tika guy actually looked at my code and said it was okay, which is really awesome for me. So I thought that was cool. I actually made it a slide. I don't know he knows, but I put a slide in there. And he did a code review of the code, and he said it looks okay. So that's good enough for you to want to start using it. And what Tika does is Tika will parse Word documents. It'll process Excel. These are things that are usually a pain if you want to do this yourself, you know, and you want to make this as part of a deep learning workflow or as part of any kind of workflow. So I'm just pulling files from a directory. I could be pulling them from some random place. I'm doing a little extra processing here because what I'm doing, I'll show you the steps. Oh, I put NLP in there too. Ignore this one. This is an Apache right here. That's Stanford. They have their own funky license. But you could still run it if you want. So we're doing this processing. It's looking at the data. This is the processor that's doing Apache Tika. So I'm passing in a PDF document, and Tika looks at it and is giving me, like if we look at this, you can't download this as a PDF. So you don't want to look at that. But it's pulling the text out of here and it's converting it into other things. I'm also, there's getting all the metadata. So I know who built it, what was the title. This is actually this earlier version of the presentation as a PDF. So I'm processing that. My thought was I would have NiFi read my presentation and then send it to Apple Speak, but it's really slow on my laptop to do that. There wasn't really good timing. I'm slightly better than Apple Speak for presentations, just a little. So it pulls out all this data, tells you that it was their PDF processor. and I take the text it returns it as different lines. It gives you one line at a time, because I thought that was a good idea. I don't know it's a good idea, but that's what I did. As you see, it produced a lot of different files. And now there's different text sections. So this is my talk. I pulled it out with Tika. It just took out the text. Tika can also pull out the images. And then I could take those images out, and I can run analysis on them. And if there's any text in that image, I could use Tesseract to pull that text out. And then I can run sentiment on that. And then, you know, it just, as much as you want to do, the tools are available in the open source to do it. So that pulled the text out. Obviously, that's a lot of text. I'm doing some additional processing. I clean it up, turn it into a JSON file, because JSON, every system in the world can read JSON. It's a very easy format to use. And what do we turn? What does this look like now? It's 2K JSON file. And I put in all that little metadata. So I know everything about that document. That might be useful for some of your security to know. Someone emailed a document. I got it in NiFi, and I could tell you everything about that document. Plus, I could pull out lines of text, analyze the text. Say you're trying to look for people who are committing fraud in your company, doing something illegal, or they're trying to hide people's personal information. I could pull that out of a document they zipped and attached to an email, automatically analyze it, and maybe it's not 100% accurate, but if I get over 80%, I could put that in a work group somewhere for a person to do the next set of analysis and say, hey, this has personal information in it. We have who sent it, when, what type of document, when they saved the document, everything about that. And now I could start doing something like maybe you have to see why they're sending those documents around. So that's just something you could do. And now it's a queryable document. I can run a SQL query live against that data based on attributes in there. Here I added that sentiment, so I could do sentiment. If it's a positive statement, do something. If it's neutral, send it to Kafka. That's kind of a neutral place to send stuff. Let someone else deal with it. If it's good, I want to store it in a file. If it's bad, send a Slack message to a DevOps group to say, hey, you guys are bad. You know, whatever you want to do there. So that's Tika. Again, another Apache project, more open source, all works together. Oh, we made it to the end on time. Everything is documented. Everything's in GitHub. Everything is open source. Everything is available for you to try. Like I said, none of things a commercial product. Everything is Apache open source. It's community supported. If you want to do something with this, just start doing it. If you see anything you want to extend, reach out to the community. Put a ticket out there, Jira ticket. You know, fork something, you know, get involved. It's all available. I don't know how much more time we have. I think we have a couple minutes for questions. And I could run deeper into any of this if you want to see more. I think we should probably get questions. I think the talk is over and you're going to have lunch. So does anyone have questions? Everything was very easy. I mean, it's all Apache. Everything's freely available. I can't see why you'd have a question. Deep learning. We did it real time. Thank you.